Today we'll be multiplying and factoring special cases. We'll be learning a few rules that will simplify multiplying and factoring certain binomials. The first ones we'll be looking at is the square of a binomial. When you have a square of a binomial, this is the rule. We'll learn this rule and apply it to make squaring binomials fast and easy. We'll also be looking at the product of the sum and the difference. A plus b times a minus b. This is the pattern or the rule for those types of binomials. So we're going to first start by giving some words, and then we'll translate it into symbols, and then we'll solve some problems. So the square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. So here's what it looks like. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. So here we have two binomials that we're squaring, or a plus b and a minus b squared. And we can see the pattern or the rules are the same, except the middle terms are different. And the middle terms match the binomial being squared. So let's start and just watch the first few examples. 5x plus 4 squared. So we're going to apply the rule and then check it by FOILing. So when we're doing these perfect squares, the first thing we need to do is identify a and b. So a is the first term, which is 5x, and b is the second term, which is 4, plus 4. So once I know my pattern, all I need to do is plug it in. A squared, so 5x squared is 25x squared. Plus 2 times AB. So multiply them together, 5x plus 4. 5x times 4 is 20, and double it. So that's plus 40x. And then square the second term. So plus 16. It's that easy. So if we were FOILing, this is what it would look like, and we certainly end up with the same result. Square the first term, square the last term, multiply them together and double to get our middle term. Let's look at this where the 5x is being subtracted. It's 5x minus 4. So it's the same procedure. We identify A as 5x, and we identify B as negative 4. Square the first term, 25x squared. Multiply the two together and double it. So minus 20x times 2 is minus 40x. And then square the last term. And again, if we FOILed it, we can see first term squared, last term squared, both terms, and it's a negative for the middle term. So if we go back and compare the two examples, they're very similar, 5x minus 4 and 5x plus 4. We can see they're identical except for the middle term. And again, the middle term, the sign of the middle term matches the binomial. So number 45, let's identify A, which in this case is 3x, and we'll identify B as negative 2. So go ahead and apply the pattern. So we're going to square the first term, which is going to be 9x squared. We're going to multiply them together, which is minus 6x, and double it, which is minus 12x. And then we're going to square the last term. Try number 46. So A is equal to 4R. b is equal to 5. Square the first term, multiply the two together and double them, and square the last term. Number 47, go ahead and try that one. $48. All right, so that's how you multiply them. So now we're going to factor. So we're going to undo the multiplication. So we know that if we square binomial, we get this trinomial. Well, then we certainly know that if we have the trinomial, we need to end up with that binomial we started with. And we know we can do this because of the symmetric property of equality. So we're going to start with the trinomial and go to the binomial. So we're still going to identify a and b. So we're going to, instead of squaring it, we're going to take the square root. So 2x. We're going to take the square root of b, which is 3. And we're always going to check that this multiplies and doubles to the middle term. And it does. So then my factor would be just 2x plus 3 squared. Okay, go ahead and try number 50. To identify my a, I'm taking the square root of a, which is 5n, and the square root of b, which is 16, which is 4. I'm always going to multiply them together and double to make sure I get the same middle term. And I do, so it's 5n plus 4. Try 51. Right now we're going to talk about the product of the sum and the difference. And that's just when we take the same terms and add them and subtract them. So in this instance, we'll be using 5x plus 4 times 5x minus 4. And the rule states that the product of the sum and difference of the same two terms, so a plus b times a minus b, is the difference of their squares, so a squared minus b squared. So identify a as 5x. And for b, well, one of them's a positive 4 and one's a negative 4. But since it's always going to be the squares, the difference of the squares, we don't care about the sign. So we square the first number, 25x squared, minus the second number squared, 16. All right, so if we were to FOIL this, if we were to FOIL this, this is what it would look like. You would get the same thing. And as you can see, when you have plus, a factor with a plus and a factor with a minus, the middle term zeroes out. Okay, go ahead and try number 54. So we just square the first term and square the last term. And it's always a minus. And again, if we were to FOIL, you can see the middle term disappears because it's plus and minus. Go ahead and try 55. All right, now we're going to factor. We were multiplying before, and we know if we multiply two numbers to get a number, then we can factor those numbers to get the factors. And again, we can do this because of the symmetric property of equality. So we're going to just work backwards here. We're still going to identify our A. So A here is 1A, or A. And our B here is a 1. So this is going to be A plus 1 and A minus 1. Okay, so we just take the square root of each number, so 2n minus 1 and 2n plus 1. Number 61, which of the following expressions cannot be factored and why? So let's just factor them all. A is the difference of a sum and a difference, so that's really x plus 5, x minus 5. Let's look at C. X plus 2, x minus 2. Let's look at D. X plus 9, x minus 9. So B is the one that cannot be factored, and let's look at Y. X squared plus 64. All right, to get a factor, two things multiplied together, to get x squared is x times x. To get 64 is 8. So if I have a plus and a minus there, I'm always going to get a minus b here. If I had a plus and a plus, that's going to give me plus 16x as a middle term. And if I had a minus and a minus, it would give me a minus 16x. That's